Simple and compound interest. Okay, let me start from the beginning. Here we go. Okay, this is for Math 0324 and 1324, Mathematics of Finance. Topics covered for today are simple interest, compound interest, and future value annuities and present value annuities. So let's begin with topic number one, simple interest. This is a formula for simple interest. I believe the book has an I only, but I just put INT to make it to make it more noticeable. But the INT is equal to PV R times T. The INT stands for interest or the fee paid to use someone else's money. The PV stands for principal or present value. The R stands for interest rate, and the T stands for time and years. Okay, for this section, I believe it's 5.1. It's going to cover two different formulas. I mean, there's like two different, there's simple interest and compound interest. But for this section, there's two formulas for simple interest. Okay, this is the other formula for simple interest is equal to FV, future value, equals to present value plus the interest. So here's how we're going to get the other formula. Okay, we're going to plug in PVRT for the interest. Now we're going to factor out, what they have in common is a PV, which is a present value. So what's left is going to be 1 plus RT, which is 1 plus the interest rate times the time in years. So these are the two formulas that we'll be using for this for this section. AV stands for the sum of principal and the interest earned or the future value. The PV stands for present value or principal. The R stands for interest rate, and the T stands for time in years. Okay, there's two things that you got to know. Okay, for example, if months are given, then the time will be given months over 12. Okay, so that's a common mistake that students make, because if they give you like 3 months, they want to put 3 for T, and it's not correct because the time has to be in years. So again, if months are given, this is what you use: given months divided by 12. Also, the interest rate must be in a decimal. So there's two ways to get the correct interest in decimal. You can move the decimal point 2 places to the left and drop the symbol, or you let me go back, or you can divide the 5% by 100 and it's going to give you 0.05. Okay, so there's two ways to get the interest in decimal. Let's do an example. Okay, example number 1. Martha borrowed $12,000 from her uncle to buy a used car. Her uncle charged simple interest at 3.5% for 5 years. Find the total amount that Martha paid to her uncle, and how much interest did Martha pay? Okay, now, which formula are we going to use? Is it this one, or the one looking for the future value or looking for the interest? It doesn't matter. Okay. What matters is that if you use the first one, the interest earned, right? If you use this one, then you have to use this one with it, because they want you to find the future value and also the interest. So it doesn't matter which one you use. Okay, but for this example, I'm going to use this first one, which is the interest earned is equal to the present value times the interest rate times the time. So this is what I tell my students to do. Okay, put every variable and then extract the info from the word problem. Okay, now it says here, Martha borrowed $12,000 from her uncle to buy a used car. Her uncle charged simple interest at 3.5% for 5 years. Find the total amount that Martha paid. So we're looking for the future value and also for the interest. So for the interest, right, this is the amount that Martha borrowed, which is $12,000. So that's the present value. The interest will be 3.5%, and the key number for the interest is always the number that has the percent symbol sign. So it give us 3.5%, but remember, we have to convert it to a decimal. So we move the decimal place 2 places to the left, and we drop the percent symbol. So this is a correct decimal form. The time, right, is 5 years. So we're gonna add. I mean, we're gonna input 5 for the t, for the time. All we do is plug everything in the formula, and then all we do is use a calculator to get a result. So the interest earned was $2,100. Okay, now this was the answer for the second part, right? How much interest did Martha pay? So the interest was $2,100. That's how much Martha paid in interest. So how much did she pay in total, right? So she had to pay the $12,000 that you borrowed from the beginning, plus the $2,100 that she has to pay extra. So that's the money Martha paid after the 5 years. And the interest that Martha paid was $2,100. Okay. Now let's do another example. Let's do the very same one, but this time let's use the other formula, the future value. Just so you know that we get the same thing. Okay, this was the other formula. So the future value, right, is equal to, like I tell my students to put all the variables down, and we're going to extract the info. But if we use this formula, okay, we also have to use the other one, which I'm going to show you right now in a bit. So this is the 12,000, right, the present value that she borrowed. The interest rate is 3.5, which is 0.035, and the time is 5, right? So we plug into the calculator, right? So we plug everything into the formula, and we use a calculator. So I tell my students to plug it in just the way it is, just the way it looks like. You see, so this gives you the future value, right? Which was the first part. Find the total amount Martha paid to her uncle was $14,100. Now this is the other formula that we have to use. Okay, the interest is the total amount, the future value minus the present value. So it's going to be 14,100 minus the 12,000 that she originally borrowed, which will give us 2,100. And again, you see we get the same result as using the previous formula. So in this case, it doesn't really matter, because at times students get confused and they'll be asking, hey, Mr. Isasi, well, what formula do we use? So if you really understand the problem, what they're asking for, this shouldn't be an issue, right? No, but anyway, this always gives a hard time to the students, because maybe they have to read the problem like 2 or 3 times. Okay, so maybe that we should, that's what we should do. Read it more than once. Simple interest continues. Okay, this is example number 2. Mariana will need to pay a tuition bill of $7,500 for her daughter in 10 months. What dollar amount can she deposit today at 1.25 simple interest to have enough to pay the tuition bill? So again, this one, okay, we're going to use the future value equals to present value 1 plus interest rate times time. Why are we using this one? Because Mariana will need to pay a tuition bill of $7,500 in 10 months. So this is the future value. This is what she has to pay in 10 months. So that's why we're forced to use this formula here. Right? So here we're looking for the money that she has to deposit today. So we're looking for the present value. Okay. So after that, we extract all the info. The future value that she needs to pay in 10 months is $7,500. The interest rate is 1.25%, which will give us 0.0125. And the time right here, the time is in 10. Well, it's in months, so it's 10 months. So remember what I put on I believe on the second slide that I mentioned, the time has to be in years. So it's going to be 10 divided by 12. Okay. Now we just plug everything into the formula, right? But this is a formula that they use in the book, right? How do they find this formula? Because if you're looking for PV, for the present value, all they do is divide both sides by 1 plus RT. So we get PV equals to FE divided by 1 plus RT. Right now, I'm going to show you how to use this formula, right? Because this one can be a little bit confusing, because you have to plug in the values into the calculator just in the right format, or else it's going to count it wrong. Okay, I'll explain that what I mean right now. So the present value, right? We plug in the future value, and then we plug in the 1 plus the R interest rate times the time and years, right? Which is 10 divided by 12. Okay, now if you want to use this formula, you can, but you have to make sure that on the bottom of the denominator you put parentheses, because it's 7,500 divided by the whole thing on the denominator. Because if not, your calculator is going to follow PEMDAS, which is the order of operations, and that's a common mistake that students make. Okay. So the answer will give us $7,422.68. Okay, now, another way without clearing the calculator. This is how I show my students, and I recommend for them to rent a calculator at the math labs. And every campus, you're able to rent it for $10. So this is a good investment to make, because more than likely, if you're taking this course, more than likely, you're not going to major in mathematics. You're going for any other degree, or you might go in for accounting. Okay, but this calculator is expensive, but it's wise to just to rent it for $10 for the whole semester. Okay, now I'm going to show you how to do it with this calculator without clearing the calculator itself. Okay, I'm going to put everything how it is, right? Plug everything how it is. So I'm going to put here on the right side, I'm going to plug this in the calculator. Okay, I'm going to enter it, parentheses, 1 plus 0.0125 times 10 divided by 12. So this is what I get. Then I'm going to hit the inverse key. This inverse key is a key in your calculator which multiplies by the inverse. For example, here we have PV, right? We have 1.014167 PV. So we're dividing, right, by 1.010416667 to both sides. But this key, what it will do it for you. So you're going to hit this key. Right, when you press on the inverse key, you should see answer to a -1. Then you enter 7,500, and it will give you the correct answer. See, that's your answer. So in other words, this will be less confusing if you apply it. If you apply this method of using your calculator. And I believe towards the end, after the next slide, I'll be using this format in solving for the present value. Okay, simple interest continues. It says here, John received a $10,000 loan from his aunt to buy a car. His aunt charged him 2.5% interest. How long was the term of the loan if the interest accrued was $125? So here, guys, we're going to use the INT formula, because the interest accrued is 125, means it's the INT. Okay, so we're going to be using this formula here. Okay, the first one. Why? Because the 125 is interest accrued, which means this is the INT. But we're looking for time now. You see, so we're looking for the time. So the interest is going to give us, this is a present value 10,000, but the interest accrued, the INT, will give us 125. Okay, and then everything else was into place. Remember that the interest rate has a percent symbol, so that's really easy to diagnose. This is the right interest rate. Now all we do is plug into the calculator. Okay. So now, right, we multiply 10,000 by 0.025, and it's going to give us 250. Then we get to divide both sides by 250, which will give us 0.5, which means it took us 0.5 years or half a year. Let me go back. Again, so it took us 0.5 years, right, which is half a year. So this is the answer that they're looking for. Hey, students, as I keep explaining this PowerPoint, if you have any questions, please put it in the chat, and the moderators will let me know, because right now, since I'm showing my screen, I cannot see who has any questions or if your hands are raised up. So just raise your hand, and the moderator will call on you, or else you can write your question on the chat, and this way I can answer any questions or give you clarification. Okay, now this is another formula that we're going to be using. In the past edition of the book that we're using right now, the simple interest was 5.1, and then 5.2 was compound interest. But now on this new edition, both simple interest and compound interest are in the same section, which is 5.1. Okay, so this is compound interest, and this is a different type of formula. So this is a formula that we're going to be using. Or, right, in my opinion, the one on the right is easier to use because the I is, if you notice, the I is equal to R over M, and the N is equal to M times T. Now, let's see what every variable means. The AV stands for future or maturity value. The PV stands for principal or present value. The R stands for interest rate per period converted to decimal. This is the only thing that's different now, okay? This and the I and the N. But the N means number of compounding per periods per period. Right now, I'm going to show you the key words for the value for the variable of M. But the time is the same number of years. Here's where the I comes in. The I is R divided by M, right? Like I said at the beginning, the I is R divided by M, and the N is equal to M times T. The I is the interest rate period, and the N is the total number of compounded periods. Now here are the key words for compounded. So every time that you see the word, the key word yearly or annually, it means that the M is equal to 1. When you see the words bi-yearly or semi-annually, my M is equal to 2. When you see the word quarterly, it means that my M is equal to 4. If it's monthly, it'll be 12. If it's daily, if it's weekly, it'll be 52. If it's daily, it's going to be 360 or 365. If the book doesn't say to use 360, then you use 365. But at times, the book might be specific to use 360 for daily. But if it's not stated, you use 365. Now, if it's compounded continuously, it's a different formula. If it's continuous, this is the formula that we use. Okay, I'm going to give you some examples of each one, of using compounded and also continuous. Okay. So this is how we use these type of problems. Compound interest. Compound interest can be used to invest a certain amount of money without depositing additional money. What I mean by that, say that you have like about $5,000 cash with you. You can actually invest it in an account that you don't have to put no more money in there, and then at a certain amount of time in the future, you get your money back plus the interest that you earned extra. So I'm going to use this type of problem, right, to explain how it can be used in the real world. For example, this is example number 4. Again, say you deposit $1,000 in an account at your bank that pays 6% compounded quarterly. How much money will be in your account after 5 years? And how much interest did you earn? Every semester that I teach this specific chapter, I always get the attention of the students. At times, some students don't really pay attention during through the year, but once I get to this section or to the chapter, everybody's focused because the interest is common, which is money, making money. So I like to give live examples so the students can understand how to use these formulas to have a better understanding about when you're going to invest or finance some type of account. Okay, now, so again, this is my formula, right? But I'm going to use this one instead because it'll be easier to put in the calculator. So for every formula from now on, for this compound interest, for the annuities, and also for present and future annuities, we're going to have to find 7 things. Okay, remember, right? 1, 2, 3, 4, 5, 6, 7. So from now on, everything has 7 things, right? So it's always wise to put them down. After you put the formula, you put them down. And this way, you'll be able to extract the given information where it belongs. But the first thing that we have to do is ask ourselves, what are they looking for? Okay, so let's see here. You deposit $1,000 in an account at your bank that pays 6% compound quarterly. How much money will be in your account after 5 years? So this means how much money will be in your account after 5 years. You're looking for the amount in the future, right? And 5 years means the future. So we're looking for the future value. Okay, after that, everything else seems to fall into place because the other amount of money will have to be your present value. And the interest is very easy to diagnose because it's a number with a percent symbol, right, which would be 6%. But you have to divide by 100, or you move the decimal point 2 places to the left and you drop the symbol. Now this is what's new on for these problems, right? So we look for the keywords. How much? Let's see here. Oh, here we go. Compounded quarterly. So quarterly stands for 4. The time is 5. Now here, what I mean over here for the formula on the right, it's easier to input in the calculator, right? So we know that the I is equal to R divided by M. So my R is 0.06 and my M is 4. So we plug into the calculator and it's going to give us something like 0.015. Now the N is the M times T. The M is 4 and the T is 5, so it's going to give us 20. So now all we do is write down the formula and plug everything in there, right? The present value was 1,000, the I was 0.015, and the N was 20. So now all we do is put in the calculator just how it is, right? We're going to put 1,000 parentheses 1 plus 0.015 plus parentheses to the power of 20, and it's going to give us $1,346.86, because you have to round out to the nearest penny. So when you round out to the nearest penny, you're going to look at the tenths place. At the hundredths place, right, which is a 5. Then you go to the next digit to the right, and if it's 5 or more, you're going to add 1 to where the second decimal place is. That's what it's going to give us 1,346 and 0.86. So after 5 years, there will be $1,346.86. Okay, now that answers the first part of this question. But the second part, how much interest did you earn, right? So this formula, right, is going to be the interest earned is equal to the future value, what you got right now, minus what you invested. So it's going to give us $1,346.86 minus what you invested, which was 1,000. So you got $346.86 extra. Imagine, guys, if this was over 1,000, say it was like 10,000, the interest earned will be much greater. This is just like an example to show you how you can make investments and actually earn money if you have a little bit of money to invest. Okay, now comes the continuous compound interest. Okay, I believe we're doing the same problem, but instead of a compounded quarterly, we're going to compound it continuously. So again, but for this formula, right, once it's continuously, it's a different formula. This is a formula that we use. Future value is equal to present value, e to the power of RT. Okay, so we're looking again for the future value. The present value is 1,000. The interest rate is 6%, 0.06, and the time is 5. Okay, so we plug into the formula. And all we do is use a calculator. But here, guys, we have to be careful. If you have like an older calculator, I believe when you hit like the caret to give you the exponent, right, it doesn't give you parentheses. But if it gives you, but when you plug it in and it gives you like a little box on top, on your calculator, you can actually put it how it is. But most older calculators, they don't give you you hit the caret, right, for the power. So it's wiser to put it in parentheses, because this is a common mistake that students make because they have an older version of a calculator. And if they put 1,000 e to the 0.06 times 5, if it's not in parentheses, it's going to give you like a wrong result, because what it does, again, it follows order of operations. So just be careful, and to play it safe, put parentheses on the exponents, right? Just the way it is here. So this is your answer, 1,349 and 0.858808, which runs out to 1,349.86. I believe this is a little bit more than the one that was compounded quarterly. So after 5 years, there will be $1,349.86 in the account. So how much interest did you earn, right? So we do the same thing as the previous slide. It's going to be the interest earned is equal to the future value minus the present value. So it's $349.86. I believe, guys, the more times that is compounded, right, the more money you're going to make. So at times, the banks, they kind of, if you don't know, if you don't know a lot about finances, that's where the bank makes money. When you're going to borrow money from them, right, it's going to be compounded, more times per year. This way, they can get more interest out of you. But when you're going to invest some money, the compounded is not that much. It'll probably be like once or twice a year, or at the most quarterly, because this way you don't get much interest. So when you go to a bank and open an account, right, like an account, so that way you can invest some money. Just tell the agent that how many times it's compounded per year. This way they know exactly what you're talking about. And this way, if they give you a certain, say they tell you it's going to be compounded like twice a year, you say that can it be compounded more times, like 12 times a year, or maybe continuous, because this way you can get more interest. Okay. Okay, now compounded interest continues. It says here, I want to be earning an annual salary of $100,000 when I retire in 15 years. I have been offered a job that guarantees an annual salary increase of 4% per year, and the starting salary is negotiable. What salary should I request in order to meet my goal? Okay, let me put it like another way here, guys. Okay, let's pretend that I say I want to retire in 15 years. Okay, it's always good to make it about you. Okay, about I, right? So I'll say I want to retire in 15 years. In 15 years from now. When I retired, I want to be getting an annual salary of $100,000. So I have been offered a job that guarantees an annual salary increase of 4% per year, and the starting salary is negotiable. What salary should I request in order to meet my goal? Okay, so again, it's going to be the same formula, but we're going to use the one that's easier for the calculator. But in this time, right, we're going to be asking, this is how much money we want, right, in 15 years. So that's going to be so what we're looking for is a present value. So we want 100,000 after I retire in 15 years. So that's 100,000. So I have been offered a job that guarantees an annual salary increase of 4% per year. So that'll be 4% will give us 0.04. And the M is going to be 1 because it says annually salary increase. So it's going to be 1, and the time will be 15. Now my I is R divided by M. So 0.04 divided by 1 will give us 0.04. And the M times T will just be 1 times 15 will give us 15. Now we plug into the calculator, right? All the info. Into the formula, my bad. But remember, guys, we're looking for the present value. So again, here, guys, when we're looking for the present value and you have numbers on both sides of the equal sign, and we're looking for PV, we're going to use the inverse, like I mentioned earlier. Okay? But I'm going to show you how we use the inverse with leaving the calculator. But this is step by step, right? But right now I'm going to show you by using the inverse. So this is the amount of money that I have to request per year. That I have to request. That's a salary that I want to get. Now here it is. Okay, easier way to put it in a TI 8384 calculator. So again, right, we're going to go straight from here, and this is the way I show my students. This is the way I think the book shows you, or if you go for tutoring, this is the way they show you, right, to put everything right. But at times we don't have time to do that, right, because we want the answer quick. So this is writing all the steps. If you want, you can do it this way. But the way I'm showing you from now on is put everything in the calculator, guys, right, without leaving the calculator. Okay. So first I'm going to input what's here on the right, parentheses, 1 plus 0.04 close parentheses to the power of 15 in the calculator. So I'm going to show you here in green what you should see and what you do every time, right? So this can be like a self-check if you're doing it right. So after you input parentheses 1 plus 0.04 close parentheses to the 15th power, this is what you should see. 1.800943506. Now you're going to hit the inverse key, right? Which is this key here on your calculator. Once you get that key, this is what you should see. You should see answer to a -1. That means the inverse. Now you're going to enter 100,000. And this is what you should see. You should see 55526, which is 55,526.45027. You see, we got the same thing as how we did it. Showing all the work here, right? And then we round off to a nearest penny, so it's going to give us $55,526.45. But the book wants you to use this. The book explains it this way. And like I said, this is good to use if you know how to use a calculator. But most students that are not majoring in math, they don't know how to use the calculator properly. That's why if you follow this method that I'm showing you, you cannot go wrong. And this in green is like a self-check if you're doing everything right. Okay. Now comes future value of an ordinary annuity, which is a different formula. Okay, I believe I'm giving you guys like 2 or 3 examples of each section because I don't want to run over time. Past my time because I have like 50 minutes for every workshop, and then the last 10 or 15 minutes are for questions. Okay, so that's why I'm doing like 2 problems from each one. Okay, this is a different formula now. Future value of an ordinary annuity. Okay, this is a formula, guys, but remember the one in the right with the I in the end is the one that's more recommendable to guys to use. And again, there's always 7 things that you got to write down. You see the future value, the payment, the interest rate, compounded. The M stands for compounded per year. That time stands for time, right? And then the I is R divided by M, and the N is equal to M times T. Okay, now how can we use these types of annuities? Okay, future value ordinary annuities can be used to accumulate funds for some time in the future. You must set regular deposits during a specific time. So in other words, here are the examples how you can use them in the real world examples, okay? And I believe we're going to go over these 2 examples that I'm going to write down here. Okay, now let's say that you can afford to save $1,000 every month, and you want to set up an annuity to make interest on the account. You want to deposit $1,000 at the end of every month for 20 years. How much money will you have at the end of those 20 years? Okay, that's a logical scenario. And the scenario say that after you get your paycheck, right, you always have like $1,000 left over every month. So if you want, you can set up an account or like an annuity for the bank to actually take away or put aside $1,000 every month out of your paycheck, and this you're going to do it for 20 years. You're going to be amazed how much money you will have and how much money did you earn in interest. Okay, here's another example. Let's say you are planning on sending your just born child to college when he or she turns 18. Since college tuition is constantly on the rise, you want to make sure you have enough money in 18 years for your child to attend college. I like to use this example because I tell students, hey guys, they were more likely if you got financial aid, right? Now that you're going to school, more likely when your kids are born, right? When your kids turn 18, then they're going to get financial aid. Why? Because you're here going to college to make money, right? To go to school and to get a job and make a lot of money, right? So more likely, if you get if you get a good job, your kids are not going to qualify for financial aid or maybe partial financial aid. Right, but you want to make sure that they attend college just like you did, because as parents, we always want to make sure that our kids are better off than we were. Okay, so this is a good example how to save money or put money in an account to send your child to college. Right, so once he or she is born, in 18 years, when he or she attends college, you have enough money for them to attend college. So I'm going to do these 2 examples so you can know exactly how they work. Again, example number 7. You can afford to save $1,000 every month, and you want to set up an annuity to make interest on the account. An investment company offers 3% interest for 20 years if you deposit $1,000 at the end of every month. How much money will you have in 20 years, and how much interest will you earn? The interest earned, guys, is like free money that you got for the bank to use your money. That's what it means here, guys. How much interest will you earn? So this is my formula. Right, remember, there's 7 things that you got to find. 7 things. So here we go. What are we looking for? Okay. So here, guys, at the last sentence, it says, how much money will you have in 20 years? So we're looking for the future value, right? So the payments that you're going to make every month are $1,000. The interest rate that they offer you is 3%. And the M is going to be, let me see here, every month, so it's going to be 12, right? The M is 12. The T will be 20. Now the I will be R divided by M. So 0.03 divided by 12 will give you 0.0025. And the N is M times T, which would be 12 times 20, I believe is 240. Now we're going to plug everything in the calculator, right? But again, let's start. If you know how to plug it in, everything at once, well, that's more power to you. But like I said earlier, most students don't know how to use a calculator. So I'm going to show you how to use it without stopping and clearing the calculator. Okay. So I'm going to show you how we got out of this. This is doing it the long way. Okay. Because if you put 1 plus 0.025, right, and then to the 240th power minus 1 is going to give you 0.8207549953. Then you divide that by 0.0025 is going to give you 328.3019981, right? And then you multiply it by 1,000, so this is what you get. 328,302. Okay, but now I'm going to show you how to put it in the calculator. Okay, without clearing or stopping, one steady flow until you reach your answer. Here we go. So you're going to input in your calculator parentheses 1 plus 0.0025 close parentheses to the 240th power minus 1. Once you enter that in the calculator, this is what you should see. You're going to see 0.82075499953 on your screen. Now you're going to hit the division key, right? Because I already got the top, the numerator here on this problem here. So now I'm going to divide. So this is what you should see on the calculator. Answer divided by on the screen. Now you're going to enter 0.0025, and then you enter. So this is the answer that you should see on your screen, right? Which is the same answer here. Now you're going to hit the times, right? Because you're going to multiply by 1,000. This is what you should see on the calculator. You're going to enter 1,000, and that's your answer. See, guys, same answer. I've done this for the past 2 or 3 years, and my students tell me that this way of checking your calculator, guys, that it makes sense because they can follow every step, and then after that, they get better and better on using the calculator. Okay, so this method, what I'm doing here, guys, in green, it actually works because here you can check every step with what you're doing until you reach the final answer. So this is how much money you have in your account now after 20 years. So how much money did you actually earn in interest? Okay, so here's what you got it. How many payments did you make? 240 payments, right? 240 at $1,000 per payment, so that was 240,000. So how much interest did you make, right? So we subtract the 240,000 minus the future value, right? So you made $88,302, guys, of extra money just by putting that money in the account. If you would have just left the money at your bank, right, you wouldn't have made as much money as this right here. So it's always wise if you have a little bit of money left over every month, actually try one of these annuities so you can make more money. You don't have to leave it for 20 years. You can leave it for 10. You can leave it for 5. You can leave it as much money that the bank permits you. Okay, but this is not a bad investment. Making $88,302 after 20 years. Okay. Now let's do the other example that I mentioned earlier. Example number 8. You are planning on sending your just-born child to college when she turns 18. You want to have $250,000 in the account for tuition in 18 years. So how much money must you deposit at the end of each quarter in an account paying 5% compounded quarterly? So in this scenario, right, say that you did a little bit of research and you found out how much will it cost to send someone to college? So I know this is a lot more that they're going tuition right now, because this will be in 18 years. So you want to have this amount in 18 years. If you want to have more, all you do is replace what you want for the 250 and the formula, and then you can get whatever you want. Okay. So let's see how much money we have to put in every month. So again, right? So same formula. There's 7 things, but now we're looking. Okay, so what are we looking for? How much money must you deposit at the end of each quarter, right? So we're looking for the payments. So how much money do you want in 18 years? You want 250,000. Here, guys, you can actually use this problem and even make it 500,000, make it a million, make it whatever you want here. I just use this scenario, but you can use this formula. Just plug in whatever you want in 18 years here for the future value. So the interest rate that they offer you is 5%, which will be 0.05. The M, right, the compounding is going to be quarterly, so it's going to be 4. The time is going to be what? 18 years, right? So it's going to be 18. The I is going to be R, which is 4. Which is 0.05 divided by 4, which will give us 0.0125. And the N is M times T, which is 4 times 18, will give us 72. Now all we do is plug everything in the calculator. Okay, but now, I believe now, guys, I'm going to use it the way I mentioned earlier, everything in one steady flow. Right, so we're going to input parentheses 1 plus 0.0125, close parentheses, to the 72nd power minus 1. So this is what you should see. You should see 1.445920268 on the screen. Then you're going to get the division key, and this is what you should see, which means this answer divided by, and then you're going to enter 0.0125, right? And then enter it, and this is what you should see on your screen now. 115.6736215. So now you're going to get the inverse key, right? Because you want to get the payment, so you're going to press on the inverse key. This is what you should see on the screen. Answer to a -1, which means this answer to the -1 on the screen. Now you're going to enter 250,000 and then enter, and this is your answer. 2161.25334. So let's round it off to the nearest dollar. So it's going to be $2,161.25. So that's how much you have to pay every quarter, which means every 3 months. Okay, now, extra information. How much money did you put into the account? Okay. Did you put the whole 250? No, right? Of course not, because you earned interest for those 18 years. So let's see how much money did you actually put into the account and how much money did you get extra in interest. So there were 72 payments, right? And the payments were for $2,161.25. So you multiply 2,161.25 by 72. So you get 155,610. Right, so that's how much came out of your pocket. So the rest that you earn is an interest, which is not bad at all, right? So you put 155,000, so you made almost 100,000 of free money and interest. How much interest did you earn? 250,000 minus $155,610. So you earn $94,390 in interest. You see, guys, so that's not bad at all, okay? Because almost 100,000 came to you as interest. Okay. Are you guys okay? Any questions up to this point? Okay, let me continue then. Now come present value of an ordinary annuity. This is a different formula now. The ones that we did earlier, on the last slide, they were called future value of an ordinary annuity. Now they're called present value. So again, right, this is a formula on the left, but this is a formula using the I to replace the R divided by M, and using the N to replace the M times T. And again, there's 7 things, right? There's 7 variables. Okay, now, how are these used for? Most common use of present value ordinary annuities are for purchasing an expensive item such as a vehicle or a house at the present time and making equal payments, including interest, for a certain amount of time. Examples. You want to purchase a car. What are your monthly payments and how much will you end up paying? You want to get an idea on the process of purchasing a house. That's the main goal for almost every person, guys, right? Getting your own house. So here is a process of how to purchase a house. First of all, these are the key factors on purchasing an expensive item and payments. First, you must have a job, right? No job, no credit, because you're gonna borrow the money right from the bank. That's why it's called present value. You're gonna borrow the money right now. So you must have a job. Must have very good credit. Bad credit. If you have bad credit and you actually get approved, your payments are going to be higher because they're going to charge you more interest. Okay, so you must have very good credit. The higher your credit score, the lower interest rate you will get. First, it's always wise to get pre-qualified for a maximum amount of a loan. Because once you get an agent, the agent is going to tell you to get pre-qualified first. Because if not, you're wasting your time. Because once you get pre-qualified, right, this way it gives you an idea of what type of homes you want to look at. For example, if you only qualify for $200,000, right, and you start looking for houses that are out of your budget. So once you start seeing like houses that are much more expensive, then once you see something that you can afford, right, to your for the amount that you got qualified for, those houses are not going to seem too nice anymore because you got used to seeing those more expensive houses. So the best thing to do is to get pre-qualified for the maximum amount of the loan. This way you'll be able to see houses on your budget. Okay, now I like to use this example with my students. Okay, now example number 9. You buy a new car that costs $26,750. What are your monthly payments if the interest rate is 4.2% and the loan is for 5 years? How much interest did you pay? Okay, let's see. So this is my formula. So what are the monthly payments that we're looking for the payments? The present value that you bought from the bank is $26,750. The interest rate is 4.2%, which would be 0.042. Monthly rights. Because most of the times when you purchase a house or a car, it's going to be the M is going to be 12 because it's in payments of per month. So the M is 12. The time is 5 years. The I is going to be R, which is 0.042 divided by 12, which will give us 0.0035. And the N, the number of payments, is M times T, which will be 12 times 5, which will give us 60. Now we're going to plug everything into the formula, right? But remember, guys, when we're looking for the payment, we're going to use the inverse key. Right, so we're going to input the numerator and the calculator just the way it is. So it's 1 minus parentheses 1 plus 0.0035 close parentheses to the power of negative 60. So it's going to give us, this is what you should see on the calculator, 0.1891185.031. Now you're going to hit the division key, and then you're going to enter, this is what you should see, then you're going to enter 0.0035. Then this is what you should see on your screen, 54.033,858.02. Now here's where you're going to hit the inverse key. Okay, that inverse key, this is what you should see. Now you're going to enter the 26,750. Once you enter that, this is what you see. So these are your monthly payments, right? Run it out to your nearest penny. So it's going to get, so your payments are going to be $495.06. Okay, now how much money did you actually pay for the car? So the payments, right, were 60 payments at $495.06. So you multiply that, it's going to give you $29,703.60. So how much interest did you pay in those 5 years, right? So we subtract. Okay, okay, we're going to subtract the what you borrowed from the total amount that you paid. So it's almost like $3,000 that you paid in interest, $2,152.60. So you're paying like if you divide that by the number of months, right? Then you can get how much interest you're paying per month. But anyway, you paid about $3,000 extra. So the car cost it costs $29,703.60, which means you pay extra of $2,153.60. This is the amount that you paid extra. Okay, now I believe this is the last one. As an example, this is purchasing a house. Okay, now you want to purchase a house for $325,000 with a 30-year fixed rate at 3.9%. What are the monthly payments and how much interest did you end up paying? Again, same formula for this section. So there's 7 things, right? So we're looking for the monthly payments. The money that we borrowed from the bank was $325,000. The R is the interest rate, 3.9% will give us 0.039. Again, the M is monthly, so M is 12. The T is going to give us 30 years. The I will be R divided by M, 0.039 divided by 12 will give us 0.00325. And the N, the number of payments, will be 12 times 30 will give us 360. So let's plug everything in. Right, and as before, we're going to plug in the numerator into the calculator. Once you do that, you enter, this is what you should see, 0.6890436901 on the screen. Now you're going to hit the division key. This is what you should see. Then you're going to enter 0.00325, and this is what's in your screen, 212.0134431. You press on the inverse key. This is what you should see on the screen, and then you're going to enter the 325,000 on your calculator, and you're going to get $1,532.921664, which runs off to $1,532.92. These are your monthly payments. Okay, now, hey guys, also please do not be deceived that you're going to be paying this much. You also have to pay for insurance, for the house insurance and stuff like that. So the house insurance depends on what side of the city that you live at. Okay, I believe the west side and the east side, you have to pay more insurance and also the property taxes. Okay, but anyway, this is just a payment for the house, not including the insurance nor the property taxes. So how much money did you end up paying? So there were 360 payments at $1,532.92. So we multiply those. So we get $551,851.20. That's how much you end up paying for the house. Now, how much did you pay in interest? Right. So we subtract what you paid. What you paid in those 30 years minus the original loan, which was $225,000. So this is how much you end up paying. Over $250,000 in interest. Okay, now how can you reduce the interest paid? You can do that by actually paying more money to the principal every month. So if you have extra money, just pay it, and you end up paying less interest and also paying the house in less time than 30 years. Hey guys, thank you guys for your time. But that's it for my presentation. And I believe we still have like 4 minutes. So maybe you can ask questions and I can answer them. Okay, but if not, I want to thank you for everything.
Okay, thank you so much, Mr. Isasi, for presenting today. And thank you to the audience for coming and being a wonderful audience. And we hope to see you again soon. Now, next week, correct me if I'm mistaken, Mr. Isasi, but we will be having the exam 2 review.
I believe so.
Okay.
But I'm not sure, Pablo, but I can check for you.
Okay, so join us next week also at 11 a.m. and we will have the exam 2 review. If we change it, we'll let everybody know. And also make sure that you all answer the TV feedback survey. You have the link posted in the chat. Click on that and answer the survey. Let us know how we can improve our presentations. And thank you so much, and we'll see you next week.
Thank you, Pablo. Thank you all.